Standard 5.1 meets is talking about whether or not you can describe what happens to the momentum, mass, or velocity of an object before and after a collision. So if the scenario is that you're standing still and your friend runs into you moving at 10 meters per second, describe what happens to the speed of both you and your friend after the collision. Now to even start with this, we need to know what the momentum equation is. P is equal to mv. What that means is that the momentum of an object is equal to the mass of an object times the velocity of the object. So as we set up this problem, we should set up our paper into a before and an after. So just with any other momentum problem that you've been doing, it's really important to separate your before and after, not only to keep your work organized, but to really help you follow what's happening. In the before scenario, there's two objects involved, you and your friend. We know that you have a speed of 0 meters per second because you're standing still, and your friend runs in and hits you going 10 meters per second. If we think about this momentum equation up here, right, P is equal to mv. If you have a speed of 0, regardless of what your mass is, your total momentum is going to be 0. If your friend has a speed of 10 meters per second, regardless of what their mass is, they're going to have a momentum. So in the before scenario, you have a speed of 0, your friend has a speed of 10. All the momentum on this side of the problem comes from your friend. In the after side, you and your friend are still both the only components of the problem. This time though, if your friend hits you and you were standing still, you're going to gain some speed. Right? You're going to be moving now. If the total momentum before needs to equal the total momentum after, and all of a sudden you have a speed, right? Now you have a momentum. So if the before momentum matches the second momentum and your speed increased, in order to keep that momentum the same, right? If you think about P is equal to mv, now you have a momentum because you have an increased speed. For your friend, if we want these two P's to add together to have a total momentum the same as before, and previously you had a speed of 0 and therefore a momentum of 0, to keep that momentum the same, your friend's mass doesn't change, so what we need to change is we need to decrease their velocity. So your friend loses speed. Now, all the momentum comes from you and your friend. Remember, the most important part here is that total momentum before needs to equal the after amount. Right? This is by far the most important piece of momentum. So again, just a quick review. Initially, all the momentum came from your friend. When someone hits you, you gain a speed. In order to keep the momentum the same in the before and the after scenario, that means if your speed increased, your friend's needed to decrease.